Hello everyone, welcome back to our channel Alchemist. Today we are going to see the p block elements. Okay, now we are going to see the location of p block elements. Okay, and this is the periodic table. Okay, as we all know, there are four blocks, that is S block, P block, D block, and then F block. And now we are going to see the p block elements. Okay, this is the location of p block elements. Now we are going to see the groups present in the P block element, that is the groups 13 to 18. Okay. The first group is group 13, that is boron family, and then the group 14 is carbon family, and the group 15 is nitrogen family, and the group 16 is oxygen family. It is otherwise known as chalcogen family, that is it easily form ores. The elements present in the oxygen family easily forms ores, or it is otherwise known as home forming elements. Okay, and then the group 17 is known as halogen family, and the group 18 is known as noble gas. Now we are going to see the elements of p block, that is elements present in the group 13 to 18. Okay, now see this periodic table. As we know that the group 13 is known as boron family. The boron family consists of boron, aluminium, gallium, indium and thallium. It is strongly marked as Ti. It is Tl. Okay. And then the group 14, that is carbon family, consists of carbon, silicon, germanium, tin and lead. And then the group 15 or nitrogen family consists of nitrogen, phosphorus, arsenic, antimony and bismuth. Okay, and then the group 16 or oxygen family, it is otherwise known as chalcogen family. The elements are oxygen, sulfur, selenium, tellurium and polonium. And then the halogen family, that is group 17, consists of fluorine, chlorine, bromine, iodine and astatine. And then the group 18 are noble gases, that is helium, neon, argon, krypton, xenon and radon. Okay, now let us see the metals, metalloids and non-metals. The yellow color boxes are metals. Okay, and the green colored boxes are metalloids, and the rose color boxes are non-metals. Okay, now we are going to see the metals, non-metals and metalloids in p block elements. Okay, these are the metals and these are the non-metals and these are the metalloids in p block. Okay, the metals are aluminium, gallium, indium, thallium, tin, lead and bismuth, or metals in p block. And the non-metals are helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, selenium, bromine, krypton, iodine, xenon and radon. Okay, and the metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, polonium and astatine. Okay. Okay, now we are going to see the trends in p block elements. Okay, the trends means it includes atomic size, ionization energy, electronegativity, etc. Okay, let's see. This is the periodic table, we know that. And on moving from left to right, the atomic size decreases. Okay, whereas the electronegativity and ionization energy increases on moving from left to right. Okay, this is left to right. And then on moving from top to bottom, the atomic size increases, whereas the ionization energy and electronegativity decreases on moving from top to bottom. Okay. Now we are going to see the general characteristics of p block elements. Okay, the first one we are going to see the electronic configuration. Okay, now we are going to see the general electronic configuration of p block elements, that is ns2np126. Okay, and this is the electronic configuration. The first member of the group, that is group 13 boron family, consists of general electronic configuration is ns2np1, and then for carbon family ns2np2, and for nitrogen family ns2np3, and for oxygen family ns2np4, and for fluorine, that is halogens, ns2np5, and for noble gases ns2np6, and for helium it is 1s2. Okay, and this is the configuration, that is the general electronic configuration. And let's see the electronic configuration for separate groups, that is for group 13 14 in detail. Okay, now let's see the electronic configuration of group 13. Okay, the general electronic configuration of group 13 is ns2np1. Okay, these are the elements of group 13. As we know that boron, aluminum, gallium, indium, thallium are the elements of group 13, and these are the atomic number. And the electronic configuration is for boron it is helium 2s2 2p1, and for aluminum it is neon 3s2 3p1, and for gallium it is argon 3d10 4s2 4p1, and for indium it is krypton 4d10 5s2 5p1, and for thallium it is xenon 4f14 5d10 6s2 and 6p1. Okay, see this: 2s2 2p1, 3s2 3p1, 4s2 4p1, 5s2 5p1, 6s2 6p1. Okay, the general electronic configuration says that ns2 np1. Okay, the period number, the period changes. Okay, we have to put for boron it is 2, that is n, we have to put as 2, and for aluminum we have to put n as 3, and for gallium it is n is equal to 4, and indium it is n is equal to 5, and thallium it is n is equal to 6. Okay, these are the general electronic configuration of group 13. Let's move to group 14. Okay, the general electronic configuration is ns2np2. This is the, we know that the elements are carbon, silicon, germanium, tin and lead. Okay, these are the atomic number. Okay, the electronic configuration of carbon is 2s2 2p2, helium 2s2 2p2, and for silicon it is neon 3s2 3p2, and for germanium argon 3d10 4s2 4p2. uh, the last ends with s2p2, that is ns2np2. The period changes 2 3 4 5 and 6 according to the period. The electronic configuration also changes. Okay, the group number remains same, that is group 14. Now let's see the electronic configuration of group 15. The general electronic configuration is ns2np3, as we know that, and the elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. These are the elements of group 14. Okay, and these are the atomic number. The electronic configuration of nitrogen is helium 2s2 2p3, and phosphorus it is neon 3s2 3p3, and for argon it is 3d10 4s2 4p3, and for antimony it is krypton 4d10 5s2 5p3, and for bismuth it is xenon 4f14 5d10 6s2 and 6p3. Okay, the general electronic configuration remains same, that is ns2np3. We have to change the number. N is equal to 2 for nitrogen, and for 3 for phosphorus, 4 for arsenic, 5 for antimony, and 6 for bismuth. Okay, that's all. The group number remains same, that is group 15. And now we are going to see the electronic configuration of group 16. Okay, the general electronic configuration is ns2np4. The elements are oxygen, sulfur, selenium, tellurium, and polonium. These are the atomic number, and this is the electronic configuration. Let's see one by one. Oxygen, helium 2s2 2p4 is the electronic configuration for oxygen, and for sulfur it is neon 3s2 3p4, and selenium it is argon 3d10 4s2 and 4p4, and tellurium it is krypton 4d10 5s2 5p4, and for polonium it is xenon 4f14 5d10, 6s2 and 6p4. Um, See this, the general electronic configuration is ns2 np4. Here 2s2 2p4, 3s2 3p4, 4s2 4p4, 5s2 5p4, 6s2 6p4. Okay, the period, the number n was increasing according to the period, and the group number remains same. Let's see the electronic configuration of a halogen family. We know that the electronic configuration is ns2 np5, general electronic configuration. The elements of halogen are fluorine, chlorine, bromine, iodine and astatine. Okay, these are the atomic number and these are the electronic configuration. And see, it is like that only, that is ns2 np5, that is 2s2 2p5, 3s2 3p5, 4s2 4p5, 5s2 5p5, 6s2 6p5. Okay, the group number remains same and the period number changes, that is n is equal to 2, 3, 4, 5 and 6. Okay, let's see the electronic configuration of group 18. The general electronic configuration is ns2 np6, and then the elements are helium, neon, argon, krypton, xenon and radon, and these are the atomic number and this is the electronic configuration. Okay, it is a complete, in noble gas means a stable configuration. Okay, 2s to 2p6, 3s to 3p6, 4s to 4p6, 5s to 5p6, 6s to 6p6. Okay, the period number changes, that is n is equal to 1, 2, 3, 4, 5 and 6. The group number remains same, that is group 18. Now we are going to see the oxidation state of p block elements. And as we all know, there are 6 groups present in p block. That's 13, 14, 15, 16, 17 and 18. These are the general electronic configuration as already we saw. That is ns2np1 for group 13, ns2np2 for group 14, ns2np3 for group 15, ns2np4 for group 16, ns2np5 for group 17 and ns2np6 for group 18. Okay, and these are the first member of the group, that is boron, carbon, nitrogen, oxygen, fluorine and helium. Okay, and these are the group oxidation state. To calculate group oxidation state, we have to know the basic concepts, that is valence shell, valence electrons, etc. Okay, and valence shell means the outermost shell of an atom, and then valence electrons means electrons present in the valence shell of an atom. Okay, and then the another concept is octet rule. As we all know, 8 electrons in the valence shell is known as octet, and it's a more stable configuration. All elements wants to attain a stable noble gas configuration or octet configuration. Okay, and now let's see, the valence electrons present in group 13 is 3, so the group oxidation state is plus 3, and the valence electron present in group 14 is 4, valence electron is 4, so the oxidation state is 4, and in this valence electrons is 5, so group oxidation state is 5. In this the valence electron is 6 and the group oxidation state is also 6, and in this the valence electrons is 7 and the group oxidation state is 7. And then in group 18 it is 2 for helium and plus 8, that is octet for other members. Okay, and these are the other oxidation state. These oxidation state can be calculated by losing or gaining electrons. Okay, when it loses 1 electrons it becomes doublet, and in this when it loses 2 electrons it becomes doublet, and or it gains 4 electrons to become octet. So like this we have calculator. In this it it loses 3 electrons to become doublet and gains 3 electrons to become octet. Okay, and these are the other oxidation state for this. If you have any doubts, put it in the comment box. We will surely help you out. And thank you for watching. Stay tuned for more videos.